Welcome back. This is part 2. I managed to get the board out and cleaned up. The board did get a bit crispy. I'm not sure if that's from the years of use, but I kind of believe that a lot of this was caused by my issue. I've got a burned up resistor here. See that? And this one here is pretty suspect. I haven't tested any of these yet. Another thing that I did was cleaned and threw a shot of deoxit into the volume control, because that doesn't look like one that's easily replaced. Not to mention, I mean, it worked fine, but it doesn't hurt to clean it up. The tuning capacitor is in good shape. The vernier dial is very stiff, and I noticed this before, but I just figured it was the radio. But I don't think so. Well, I mean, this is pretty stiff. So I shot some WD-40 in here. You know, I wrapped a paper towel around it and let it try to soak in, and it did work some stuff out. So I'm just thinking I might suspend this and dip it in some, I don't know if I want to use denatured alcohol, see if I can get some of that junk out of there. I don't really want to take it off, although I could. It would not be too difficult to figure out how these go back on, but it is a bit of a pain to try to get all of these cleaned up and pulled out. Although I guess it's better on one of these old circuit boards than a newer one. One of the things I noticed is this is all kind of coated in wax on the bottom. More heavily concentrated in this area. At first I thought it might be from the capacitors, and I guess it is very well possible if when I pull this one out all the wax is gone from the inside. But there just seems like an awful lot of wax on here to be leaking out of a cap. Although, like I said, it could be. Another thing I would not recommend with these is, you know, that the dust bunnies that got burned up were kind of stuck on there, and you can still see some of the white that's left. So I didn't even think about it. I used 99% alcohol on this, and at first I thought, wow, this is really dirty, it's really dirty, but it's whatever they coat the top of this in, the alcohol is a really great solvent, so it re-solidified and it's not sticky, but you can see on these really shiny places where it actually pooled up. I don't know if you can see here because it got stuck, it pooled up under the rim here. So definitely don't want to clean these with alcohol. The tubes turned out okay. They all tested okay. The 50C5 is a bit weak, but you know, it worked. The tube we could not see burning was the 6BA6 or 12BA6, and the reason for that was the filaments on the bottom are pushed up in the cathode a bit, plus they're teeny weeny, and the top here there's this black cap over it, and since it was facing sideways, that's why I couldn't see the tubes glowing. But this tube tested actually just fine. The 50C5 and the gets extremely hot, really hot. That's the side here that's the darkest. This is where the 35W4 goes. I think that's the reason why these are in the back. On most of the schematics, these are the closest to the back near the vents from a lot of radios. So, as I mentioned, I know this one gets really hot because the top of the set, when it's normally in use, gets pretty hot. And on the top of the other clock radios, the first modern plastic ones, I've got one in the other room, it's a little warped right above where the 50C5 is. So I assume in later years they changed the design just a little bit, or they went to a different, well, I don't know if the heater makes a difference or not. I was thinking they might go to a 35C5 But that would need a dial lamp anyway. I'm starting to ramble. Anyhow, I'm going to go ahead and I may soak this, as I said, in some rubbing alcohol. See if I can get some of that gunk out of there. More gunk, because it's hard to turn. It's fine when I put the knob on it, but you know, I was really lucky because the original knob on it was missing, and I was really lucky to actually find somebody that not only carried knobs that, well, everybody said he was the knob guy, but I just happened to mention to him I had this odd seafoam green, blah blah blah, rare, and he came back with, oh, I have one of those. So anyway, it's a soft plastic. I'm sure most of them broke. Anyway, so if I could get this to be a little looser, I'd feel a little bit better. So I'm gonna see what I can do, a little bit of cleaning, like I said, and I'll be back in a few. Okay, well, I messed with the tuning condenser for a while, and I got it to be a little bit better. But unless I could figure out how to take this out without ruining it, it's just gonna have to be this way. So I went through and tested the resistors, and just about all of them were in tolerance. Well, a couple of them were outside the 20%, and they were banded at 10%, so I went ahead and did it. This is 150, I believe. This was the 150, I don't remember now. Anyway, so there was a total of 1, 2, 3, 4. Believe it or not, the one that was toasty, actually, it tested out at 120, and it's supposed to be 120. Now, see, now I got it all backwards. Let's see, yeah, this is supposed to be 150 here, and it reads out at 100. Read out at like 120 or so. So since it was all fried anyway, I just went ahead and replaced it. And this one here, the other toasty one, was a 27 and 27 ohms, so I replaced that. This one here was a bit out of tolerance. It was a 1 watt, and I only had 1 watts anyway, so I replaced that. Yeah, that is it. I got to one of the caps here. I got replaced 0.02. What else? No, that's about as far as I got on it. So I think I'll pick it up tomorrow, and we'll see. I'm gonna have to do the electrolytics. I've got the right ones. I have to do this regular capacitor here. This here is a combo unit, so I'm hoping that it's good, or at least the resistors are good, because although they do give instructions in here, it's part number C. Where is it? It is R7 and C4. So it contains a 220 picofarad, two 5,000 picofarads, and then it has a D and an E, which it says that if you're replacing the items individually, to make sure that D and E equal 250. So I'm assuming they must be connected together. And where is that? is it? C4. Okay, so it's shown. Oh, hello. It's got dotted lines on it. Hello. So it's all contained within this unit, and I guess D and E. Oh, D and E connect. C connects between D and E. Alright. Interesting. Somebody will probably chime in and tell me why they would have done something like this, but there was something, and when I was reading about the placer for plated circuitry, I think is what it stands for, they talked about stacer as well, which is, or stasser, which were stacked combo component units. Oops, I didn't realize you couldn't see. So, anyway, we'll take a look at that too, I guess. Hopefully we won't have to deal with it, like I said. So I'll get the electrolytics tomorrow, and I'll do this here, and then we'll go ahead and try and fire it up. I make that sound also simple. Anyway, so I will see you guys in a bit. Hello, welcome to Sunday. So I worked on this a little bit more yesterday, or I mean this morning, excuse me, and I went ahead and replaced the 0.05 with a 0.047, and I've got a 56. Where is it? I put a 56 microfarad electrolytic and a 33 in the place of the 50 and the 30. Something I forgot to mention yesterday was I've been having a hell of a time with this because of the burnt out sections. The adhesive, or the whatever they used to glue these traces on, has become pretty messed up where it's burned up, where it was burned up. So I actually pulled a little bit of the tracing off. It was much more damage up when I removed this. As far as I could tell, this pretty much it pretty much reads out okay. The resistor portions are a little bit high, but you know, they're within 20%. So since I don't have a any sort of a guide, and I can't say that I actually looked, that tells me what each of the pinouts do on these. You know, I kind of had to fake it through it, and I found a couple of 496Ks. I'm assuming those are the 475 in the schematic, a 7.2, which is the 6.8 section. I suppose I could follow the traces to be absolutely sure, but like I said, it came out pretty much the way it should. And the portions, the sections that are the ceramic capacitors, of course, we figured would be okay, or I did anyway. So as far as I can tell, it was good. I could tell you what I guess I figured out where the issue was. The 0.02, where did it go? The 0.02 is open. I mean, not open, is shorted. Big time shorted, actually. I'm getting half an ohm on it. If it still measures the same, there you go. And of course, if I mean, there we go, we got a short. And it no longer reads capacitance, so what that was doing is, on the schematic, My silly piece of paper is coming out. All right. So on the schematic, that would be okay, so here is C5. It's 0.02. So it connects up over here, goes to the 150 ohm to ground, and connects up to the cathode and the beam on the 50C5. So by that opening up, that 110 volts came through here and flooded right onto the cathode, which is only supposed to be 5 volts. So I'm going to assume that's part of my problem. As I had mentioned, the 150 actually read okay. I mean, it was out of tolerance, but let's find it over here. I'll tell you what, this thing just got all sorts of crunchy and even kind of melted itself to the board. So I'm assuming that's where the problem lies. I don't know, you know, I was taking a look at this. I don't see, except for the fact that it would have also flooded B plus voltage onto the B minus line. I'm wondering if that's why the filaments went kind of ape poopy over on the 35W4. I guess we'll find out when I put it back together. Also, I was thinking, you know, I hope this thing does not need alignment, because the alignment instructions, the slugs on these, there's there's 2 adjustments in each of the cans. Well, one's on top and one's on the bottom. So you have to align part of this radio outside the chassis and then move it back in so you can do the dial and then adjust these 2. There's not a lot of room in there. So yeah, that's gonna be kind of a pain in the ass. So what I did with the traces here, they look actually pretty good now. I'm sure somebody's going to get on my case for this, because instead of using a jumper wire, usually you would use a jumper wire or even a pen. But these didn't tear, they just lifted off. And as I'm ducking, because somebody's going to cringe the moment I say, I just used the gel to glue it back on. It worked. Anyhow, so I'd accidentally ripped this one off, this one. The pads are kind of missing, and it's going to be a little bit messy, because on the top here I also ripped this one all the way back to here, and I think that's it. Oh, and the pad's missing from here and here, but you can't see that from here and here. But there's no trace on the top. It's just an anchor point, so I think we're okay. And I'll check it for continuity. I haven't soldered this back on yet. I just wanted to get going on getting another brief video up there. So I think what I'm going to do is make this the end of part 2, and then I'll start up a part 3. And that'll be when we try to power it up for the first time. So thanks for watching and spending a little bit of your weekend with me. And I didn't do it in the last video, so I apologize. I wanted to welcome the new subscribers. Welcome, and shout out to Brian, a friend of mine out in California. So and if he doesn't come back and say I heard your shout out, then I know he's not watching my videos, the little brat. Anyway, thanks a lot, and I'll see you in the next video.